Before Hurricane Milton even made landfall earlier this evening, the National Hurricane Center warned it would become one of the most destructive hurricanes on record. Scientists and experts have been alarmed by Milton's historic size and its strength, and also the supercharged rate at which it grew, what is known as extreme rapid intensification. The cause for that is fairly straightforward. Unusually hot ocean water, especially on the surface, provides fuel for these storms. And this year, the Gulf of Mexico saw record high temperatures. Scientists are clear that a primary reason for that is climate change. According to a recent study, climate change made the record-breaking water temperatures that fueled Hurricane Milton up to 800 times more likely. Author of the New York Times bestselling book, The Heat Will Kill You First, Jeff Goodell, puts it plainly. Hurricane Milton is a fossil fuel-driven catastrophe. Joining me now from Asheville, North Carolina, a city that is still reeling from the effects of Hurricane Helene, is Jeff Goodell, a journalist who has covered climate change for decades. Let me first just start with the idea that climate change is making a storm like Milton 800 times more likely. Do you concur with that? Does that sound right to you?
Yeah, I mean, the study you're citing suggested that global warming is making the sea surface temperatures 800 times more likely to reach these temperatures, which is making this hotter temperatures, as you talked about in your introduction, more likely. So it's not making the storm itself 800 times more likely. It's making the hotter waters that are driving these storms much more likely. But we do know that because of these hotter waters, hurricanes are not only more likely, but more intense, more destructive. We have seen that with Milton, with the rapid intensification of the storm and going from basically a tropical depression to a Category 5 storm in 48 hours. And I think what we're really seeing is, a sign of this new climate that we are creating by continuing to burn fossil fuels. We're going to see more and more of these kinds of storms. This is not a freak storm. This is not just a kind of random event. This is, the kind of world that we are creating for ourselves.
We talk about rapid intensification, or have a lot in the last 12 hours, because it's a hallmark of Hurricane Milton. But it seems like it's a characteristic of several of the hurricanes that we've weathered in the last, I think, 2 years. Hurricane Otis in 2023, Hurricane Idalia in 2023, Hurricane Ian in 2022. I mean, those are Category 4 and 5 storms that intensified rapidly. For people who don't quite understand why that matters, could you explain the phenomenon of rapid intensification and why it makes these monster storms more perilous?
Well, I mean, let me start with the idea that, about 90% of the additional heat we put into the atmosphere with CO2, which, traps heat in the atmosphere, goes into the ocean. The ocean is like a giant heat sink, and it sucks up a lot of the heat. So as we get these hotter oceans, hurricanes are like heat engines. They work off the differential. They get their energy from the differential between the ocean temperature and the cooler temperatures at the top of the atmosphere. And so as the ocean's temperature increases, that sort of heat engine spins faster. And a faster spinning heat engine like that is very dangerous because, first of all, it is much more difficult to predict. These things happen very quickly. They come out of nowhere. They spin in sort of much faster, much larger diameter. They are, because of hotter air carries more moisture, so they are wetter. Which is really important. We're seeing that here with Milton as the rain begins to fall. For every 1 degree of a warmer atmosphere, you get 7% more water in that air. So you're getting more intense rainfalls, which is something that we saw in another unlikely place like Vermont last summer. We had these intense rainfalls were very, very damaging. It wasn't a hurricane, but it was because of this hotter atmosphere carrying more water. So, and then when you add the final thing onto this, which makes these more destructive, is sea level rise. I mean, the Gulf Coast, its sea levels are rising twice as fast as the rest of the United States. We've seen 5 inches in just the last decade, and that's just going to accelerate. And so all these factors together is what makes these storms much more destructive.